Okay, good morning everyone. So this one is actually the waveforms of an AC signal. Okay, so this is actually a sine wave. Okay, so when we are required to write an expression for a signal, it can be the mathematical expression, which is what I'm going to do now in the next two videos. Okay, so this is the first way how we can write the mathematical expression. First, before that, we have to know what is the parameters needed uh, to write an expression for a signal. Okay, this is the signal of sine wave of signal. We call it sinusoidal wave. It start from zero. Okay, start from zero, so means this from zero. Okay, so what is the parameter needed? Is these six parameters. The first one is the amplitude or the peak value. The peak value is the what we call it puncak. Okay, this one. Okay, so this is the max voltage, maximum voltage, or we call it VM, or sometimes we use VP. Okay, VP or the peak voltage. So the one is when having the most lowest value is the negative VM. Okay, so this is the value. So the voltage value is we call VP, from 0 to the maximum, or another parameters sometimes they ask is the peak to peak value, which is from this peak to this peak. We call it V peak to peak. Okay, so from this peak to this peak. Okay, not from this peak to another peak. And sometimes the student confused with these two peak. This is not voltage peak to peak because they having the same amplitude. Okay, so the V peak to peak is this peak until the most lowest peak. Alright. Okay, alright, this is the first one. Okay, and then the second one is the angular frequency. Angular frequency sometimes it's easier if you can recognize these symbols, omega. So how to get omega is actually depending on the frequency. That's why we call it angular frequency, which coming from the equation 2 pi f. 2 pi f. Okay, so how are we going to calculate the angular frequency is by find the frequency first. So how are we going to get the frequency is actually depends on the time and the period, which is actually the same. It's the symbol is the time, it's a second. Okay, so what is the time or the period? Actually is the period. Okay, what is the period of the signal is actually the time taken to have to complete one complete cycle. This from 0 back to 0, complete cycle, not until here. This is only half cycle. So this is the period T, here T. Okay, sorry for the camera. Okay, so T. Alright, so how much time taken, how many time taken to complete a cycle? So you call it the so for the frequency is actually coming from the time taken to complete cycle is T, 1 over T. Okay, so it depends on the time for the complete cycle. For example, if you have a high frequency, that means that you have a very low time, very small time. Okay, and if you have a lower frequency, the time taken to complete one cycle is very high. Okay, for example, if we have T equal to 1 second and T equal to 100 milliseconds, so what is the difference between them? So you will have different frequency. Okay, for T equal to 1 second, so the frequency shall be 1 over 1, which is 1 hertz. Right. Okay, so for T equal to 100 millisecond, so if we can use calculator, so the frequency is 1 over 100 millisecond equal to, so if we can calculate here, 1 over, you can see 1 over 100 millisecond Okay, milli is 10 to the power of minus 3. Okay, so equal to 10. So for 100 millisecond, the frequency is 10 hertz. Okay, alright, so that is the calculation how we can calculate the frequency. So from the frequency, we can definitely calculate the angular frequency, which is 2 pi f. Okay, for if the time is 1 second and the frequency is 1 hertz, so the frequency, the angular here is 2 pi radian per second. Okay, for the omega. So for the omega for 100 millisecond, because of the frequency is 10 hertz, so 2 pi 10 equal to 20 pi radian per second. So that's how we calculate the omega. Okay, next we will explain, I will explain about phase angle in the next video. Thank you guys.